Good morning, class. So, yesterday I failed to send you the video. So it is if we missed the lesson completely yesterday. But it's fine. You guys didn't see the reason to send me a message either. But anyway, you win some, you lose some. No? Right, we're looking at the example on page 67. Okay, let's start again. Example 1 on page 67, we are told that consider the function f of x equals x cubed minus 5x squared minus 8x plus 12. Let's make the side right. There we go. The first question says determine and classify the stationary points. So stationary points to us is turning points. Okay. It's turning points. So how do we work out our turning points? Work out our first derivative. We said equal to 0. So the first derivative on f here is f prime x equals 3x squared minus 10x minus 8. So that's a general gradient anywhere along the curve. So what do? I set it equal to 0 to get a gradient at the turning point. So equal to 0. So x is equal to 1 of 2. It's going to be 3, negative 10, negative 8. Okay. So they give you x value of 4 for an x value of minus 2/3. Alright. So what do I do with that then? I substitute f of 4 into the original equation. So it's going to give you 4 cubed minus 5 times 4 squared minus 8 times 4 plus 12. Work that out. As well as f of minus 2 over 3. Work those two out for me quickly. Walaikum salam. Fine. Alhamdulillah. Sorry? Class. Today is Wednesday. Last period. I'm free. Last period today. Okay, so f of 4 works out to give us negative 36 and f of minus 2 over 3. 400 over 27. Okay, you all agree with that? So the coordinates of the turning point is going to be 4 and negative 36 and negative 2/3, and 400 over 27. So now if you look at this graph here, the shape of the cubic graph, if that number, if you got f of x equals ax cubed plus bx squared plus cx plus d, if a is greater than 0, the graph goes up then down. So as you can see here, the maximum precedes the minimum. The maximum comes first, then the minimum. On the other hand, that's your maximum, local maximum, local minimum. No? So if a is less than 0, the graph goes down then up. So the minimum precedes the maximum. So the graph is going to look like that, or like this. This is when the turning point and the point of inflection is the same. Okay? Here the turning points are different, and the point of inflection is between the two. Can you see that? Otherwise, that one would also be a case of where the turning point and the point of inflection is the same. Okay. So if a is greater than 0, and in this case the graph will go up then down, which means to say, which one comes first? The maximum. So which one of the two is the maximum? Where x is 4, x is negative 2/3. Which one comes first? You're saying x is 4 and then 2/3? Or you're saying negative 2/3 and then a 4? Negative 2/3 come first, not so? So this is going to be our maximum, the local maximum, and this is your local minimum. There we've classified it. You all okay with that? Yes? Sorry? You see that this is positive. Okay? If the graph is positive, the graph goes up and down. You will see when we do this graph how it's going to look. Okay? So now, if you're going to say, coming from left to right, which one comes first? Negative 2/3 or 4? Which one comes first? Negative 2/3. So this has to be negative 2/3. And 400 over 27. And this one is your local min, which is of course 4 and negative 36. And we can even see it from our y value. Can you see that? Not so? Is 400 over 27 not larger than negative 36? Huh? So therefore that's another reason why that would be your local local maximum and local minimum. Alright, any confusion there? Alright, so you know, write that down. It's a bit smaller. Okay, so what was that? Negative 2/3 and 400 over 27. And the other point was 4 and negative 36. Okay. Number 2. Number 2. Number 2, it says determine the points or the points of inflection. How did we say? How do we work out the points of inflection? We work out the second derivative. Now remember, our first derivative was 3x squared. Just right here, f prime x was 3x squared minus 10x minus 8. Now if I apply my derivative again to that, which is my second derivative, what do I get? Sorry? 6x minus 10. So what do I do with that? So it's equal to 0. So that is where the point of inflection occurs. We solve for x. Once we solve for x, we substitute that x value into the original function again. Do you guys understand? Do that quickly. Right, so when you set it equal to 0, that would imply that x is equal to 5 over 3. You then get f5 over 3. So you're going to get 5 over 3 cubed minus 5 over 3 squared, negative 5 into 5 over 3 squared, minus 8 times 5 over 3 plus 12, which is negative 286 over 27. Yes? Yes, you may write it decimal if you like. So I'm going to put here, so that's your turning points. The point of inflection was 5 over 3 and negative 286 over 27. Don't forget to write it in coordinate form. Okay, don't forget to write in coordinate form. So that was the question. Okay. Number 3. Look at number 3. Determine the roots. What are roots, people? Roots are x-intercepts. Not so? How do we normally work out our x-intercept? By letting y equal to 0. Not so? So, f of x, which is x cubed, minus 5x squared, minus 8x plus 12 equals 0. Now we've dealt with this before. Not so? We're going to, first, when we did the chapter on polynomials and factorizing this cubic function, the cubic equations and expressions, we first go where f is 1. If that doesn't work, we try then negative 1. Then we do f of 2, then minus 2, 3 and minus 3. You all agree with that? Now you find the factor for me, and then you factorize this equation completely. Alright, so what gives you 0, people? Which factor gives you 0? Sorry? 1. So f of 1 is 0. So therefore, x minus 1 is a factor of f of x. You all agree with that? So now I say x minus 1 into equals 0. So x multiplied by what will give you x cubed? X squared. Negative 1 multiplied by what is going to give you positive 12? Negative 12. You all agree with that? So I must end off with negative 5x squares. The only way I'm going to get x squares by multiplying negative x, the constant by x squared, which gives you negative x squared, and then x by an x gives you an x squared. The question you're asking yourself, what must be added to negative x squared to give us negative 5x squared? What must be added? Negative 4x squared. Negative 4x squared divided by x, negative 4x. Okay? So what do I do now? I can factorize this trinomial here, not so? Let's go further. I can either use the quadratic formula, or I can use the roots, the factorization, or I can use the calculator. Okay? So this will give us x minus 1. So that gives us x, for 12 is going to be 6 and 2, minus x plus So x is equal to 1, or x equal to 6, or x is equal to negative. Okay. Any confusion there? No? For those of you who have the silver calculator, you do it as follows. As follows, press mode. Guys, did I show you to do this already? Yes? The cubic function. Okay. Mode 5, 4. The coefficient of x cubed is 1, of x squared is negative 5, of x is negative 8, of constant with the d value is 12. Oops. 12. 6, which we have 1 and negative 2. Okay. So those are the roots. Do this up here. The number 3. Theta was x is equal to 1, x is equal to 6, x equal to negative. Okay. If you look at number 4, they ask you to sketch showing the intercept of the axis and the coordinates of the stationary point of points and the point of inflection. Okay. So you guys draw the graph and plot those points on the graph. Okay. Pause the video at this point. Okay, so the first thing we normally draw in is our intercepts, not our x-intercept. At this point we could have worked out our y-intercept as well. What's the coordinate of the y-intercept? 12. You all agree with that? Once I show you how I got 12. You all know I got 12, eh? How did I get 12? Let's say x equal to 0 is. Okay? So x is negative 2. It's all by approximation. X is 1 and x is 6. Okay? And remembering the graph goes up then down. Okay? Then at negative 2/3, if that's negative 1, negative 2/3 is approximately there. And on negative 2/3 is turning at 400/27. Negative 2/3 turning at 400/27. Okay? Then at 4. So there's 1, 2, 3, 4, 5, 6, no? At 4. And the x value of 4 is turning at negative 36. You see that, people? So this is a turning point here, and that's a turning point there. So from the turning point we draw the graph, going down like that. There we go. That is your cubic. Okay. Any confusion there, people? Okay, all okay with that? Right. The next question says, what is the maximum value of f of x for x is an element of negative 3 to 10? What is the maximum value? Okay. So if you look at, where's x negative 3? If this is negative 2, then negative 3 is about there. Not so. So somewhere along here, you got negative 3. Then you got the graph goes here, that's a local maximum. Can you see there? This corresponds to 27 to 70. To 17, so that's about 13, 14, 15. What is 400 over 27? Sorry? 14,81. So you see, from negative 3 all the way to 10. Can you see that? 10 will be approximately on the graph. Don't miss so much. I go down and I got 10 here, and I extend this graph. That 10 will lie here somewhere. You all agree with that? So it could be that that 10 could be a bit lower than this. Not so. So the candidates for the maximum on this graph is either at negative 2 over 3 or it's going to be at 10 and some y value. Does it make sense? We go again. The question says, what is the maximum value for x is an element of from negative 3 all the way to 10. So only for that part of the graph we need to look at. If you look at negative 3, this is the minimum value. I won't even calculate that value there. Why? Because all these values are already more than what the x value is at negative 3. Can you see that? Then it goes minimum again, local minimum, and then it looks like this graph is going past the point of 14,3. Can you see that? But we can't be too sure. So the candidates for the maximum value is at that point or at 10 and some y value. Can you see that? So what do? I need to calculate the y value at 10. So I substitute 10 into f of x. Substitute 10 into the original equation. Y into the original equation so that can you work out the corresponding y value at that point. F of 10 gives us what? F of 10 gives us what, people? 430. So what is your maximum? The maximum is at 10. Not so? Because that is definitely more than what the local maximum at the negative 2 over 3 and 400 over 27 is. Can you see that? The question is, what is the maximum value? So therefore, the maximum value of 432. Okay, does it make sense? Okay, so something else I need to, okay, before I go into what I want to explain there, let's take this off, this blue. Number 6 is, use your graph to determine f of x as x approaches negative infinity. As x approaches negative infinity. So if x approaches negative infinity, what happens to this graph? So it's going to approach. What will happen as x approaches negative infinity? What's going to happen to f of x? It goes all the way to negative infinity as well on your way. Can you see that? So what happens is if f of x as x approaches negative infinity, the function also approaches negative infinity. What will happen if f of x, if the limit as x approaches positive infinity? what's going to happen to this graph? The graph goes to positive infinity here as well. Can you see that, people? If the graph had gone the other way, what will happen as x approaches infinity? If this is g, the limit as x approaches infinity, what will happen to this graph? It will go to, what is this? Positive or negative infinity at the bottom? Negative infinity. This is of g of x now. No? It would be negative infinity. What will happen as the limit as x approaches negative infinity of g of x? What will happen? This graph will approach positive infinity. Can you see that? So it's depending on the end arms at that point. Okay. Another question that comes in often is the tangent. We have done a lot of tangents at this point already. Not so. So the tangent is associated with this graph. They would ask you to determine the tangent at 6, at x equal to 6 or x equal to 1 or even 4, whatever. You guys have done quite a few tangent calculations at this point. Not so? The other point I want to speak about is a common asked question is if, you can write this down, if f of x equals k, determine the value of k for which the graph will have the function of f for which f will have, in the first case, 1 root. The second case, where the graph where k will have 2 roots. And the third case, where the graph will have 3 roots. Okay, we're going to answer all 3 of those. People, one of that comes in or none of that comes in. Okay, you're not going to get all 3. Okay, you get one of them. So I'm going to explain it at this point. Okay, so take it down. Okay, so if f of x equal to k, determine the value of k for which f of x will have, the first case, 1 root. Okay, so if I take this into account, I'm going to redraw this graph. I'm going to redraw this graph quickly. Whoops. Did I draw the y-intercept on that graph? No, I should have, no? Just plot the y-intercept. What's the coordinates of the y-intercept there? 15. 12. Okay, so this turning point here, was 1, 6 and negative 2. No? So that's a nice representation. That should be a bit better. So what's happening? It's your y and this your x. Not so. This point here was negative 2 over 3 and 400 over 27. This coordinate here was 4 and negative 36. And this point here was, okay. Now coming back to the question at hand. The question says, for which values of k will we have equal root? One root. Yes, morning from Saddam. Just hold on. Huh? Change now. Okay. So one root. So we see that the roots are your x-axis, not so. So if I draw an x-axis here, then how many roots would this equation have? As it stands there. What are roots? The roots are x-intercepts. So how many roots do this equation or this graph have at this point? 3 roots. Can you see that? Now if you're looking at f of x equal k, okay, you all agree that there has to be a y value. No? Where the function is equal to. So it has to be a y value. You all agree with that? No? So we have 3 roots there. So if I take this line, remember now, this is the y is equal to k line. Not so. This is the y is equal to k line. Alright? If I take this point, okay, and I put this line here, then how many roots does k have now? Will the graph have? Sorry? 3 roots. Not so? There's 1, here, 2, 3. You all agree with that? Okay. So it's still 3 roots. Now, how many roots would you have here? 3 roots again. 1, 2, 3. So if I put it anywhere between these two turning points, what do you notice? There's 3 roots. Can you see that? So you'll have 3 roots here, all the way till here. So of course it has to be represented as an inequality. Not so. What will happen if the graph goes through there? How many roots has the graph there? How many roots does how many roots are there at that point? 2 roots. Is the turning point, and yes, there's 2 roots. Okay. So at which value of k will we have 2 roots? K is equal to 400 over 27. So for 2 roots, k is equal to 400 over 27. Or, we'll bring that a bit down. Bring that down. How many roots would we have there? Also 2 roots. Not so. And what is your y, your k value at this point? K is equal to negative 36. Okay. You all agree with that? Right. Now, if I bring that down, I bring this point down, this line down, then how many roots are we going to have here? How many roots are we going to have here? 1 root. Not so? We're going to have 1 root there. But if I bring this up, 1 root. Can you see that? So it will have 1 root when? We will have 1 root where k is less than negative 36. Or it will have 1 root where k is more than 400 over 27. Can you see that? Again, where it has 3 roots, it's between those 2 turning points, not so? So is this a continuous or a break-in solution? Continuous solutions together. So what am I saying? K with 3 roots. K must be greater than negative 36, but less than 400 over 27. Okay, you'll get quite a few of this here. I like asking this question, so look out for this question. Okay. So normally 2-3 marks we learn. Let's just leave out. Okay. Alright, so that is the first example. We're going to go a bit quicker through the second example. Worked example 2, and this is on page 168. Example 2, page 168. Example 2, page 168. Okay, we are told consider the function g of x equals x to the 3 minus 9x squared plus 27 plus 37. The question says determine and classify the stationary points of G. So where do we start off, people? We start off by saying, how do you work out the stationary points? Yes, your first derivative set equal to 0. So what's the first derivative here? 3x squared minus 18x plus 27. Not so. Set equal to 0. So I can drop that. So again, you can either use the quadratic formula or your factorization, or you can use the calculator. So that's going to give us 3, negative 18, 27. So that's an x value of 3. And an x value of you see, they only gave you one x value. So which means to say this is a perfect square trinomial. Okay? So it's going to be 2 of the same. But you'll see now this affect us. Okay. Just check if it's easy before we do all these calculations and something else. Yes, it's correct. Okay. So what do I do with that? How do we get the corresponding y value? Substitute it back into the original equation. So g of 3 equals 3 cubed minus 9 times 3 squared plus 27 times 3 plus 37. So that gives us an answer of 3 cubed. 3 cubed minus 9 times 3 squared plus 27 times 3 plus 37. That gives us 64. Okay? 64. So the coordinate of the turning point is going to be 64. 3 and 64. So what did we say when the turning point, remember when you take this graph into account and we stretch this graph, it's going to look something like that. So you still have local max, local min. Okay, but very close. If you stretch it out in such a way that the two local maximum and the local minimum is at one point, then the point of inflection also occurs at that point. Okay, moving from concave up to concave down. Okay, so it looks like this will be an example of that case that's happening. Okay. Then it says discuss the concavity. The concavity which is concave up and concave down. Concavity is dependent on, this is 64 here, I'm going to take this off here. So it's 3 and 64. The concavity is dependent on your point of inflection. Not so. I could have done the concavity calculation here as well. Before I forget, coming back here, sorry man, to this, I know the question wasn't asked, but we have actually worked out the point of inflection, not so. What was the coordinate of the point of inflection? It was 3 and 2 and something. Sorry? What was the coordinates of the point of inflection? 5 over 3. So it's negative 5 over 3. And negative 286 over 27. So here you see what you notice, the graph is concave down. So if the question is, for which values of x is the graph concave down? Is concave down for x's less than 5 over 3. Can you see that? Where is the graph concave up? Is concave up for x's more than 5 over 3. It asks you one of the two. Okay. Coming back to this here. Discuss the concavity of G. Same story then. As you can see the graph, the turning point and the point of inflection is happening at the same point. Not so. So what we do is, this is positive. So the graph goes up then down. So in this case, it can go up and up. Not so. That's what happens if the two turning points are together. So the point of inflection is here, which is 3 and 64. Now on this side of the graph, if I draw a straight line, okay, would that be considered as concave up or concave down? This part. Would this be concave up or concave down? Concave down. Why? Because the graph is below the graph is below the tangent at that point. Can you see that? That will be the case until that point of 3 there. Can you see that? On the other side of 3, what do you notice? It's concave up. So if when they ask you with regards to concavity, you answer the question as follows. The graph is concave down for x's less than 3. And the graph is concave up for x's more than 3. Okay. Let's carry on. Number 3. Show that x minus 1 is the only root. So what does root mean? The root means to say it's an x-intercept. That's all. So what we do is we say g of minus 1 is equal to 0. We know that. That's given to us. Okay?
Hi, sir.
How are you? Alright, so we know that g of x equal to 0. A g of negative 1, because that's given a factor. So x plus 1 is your other factor. We then need to work out our quadratic. X times what is x cubed? X squared. 1 multiplied by what is 37? 37. Not 36. That's going to give us x squared. Not so. So what must be added to x squared to give you negative 9x squared? Negative 9x squared. What must be added to x squared to give you negative 9x squared? Negative 10x squared. Not so. Negative 10x squared divided by x is negative 10x. So if you work this out and you put this in your quadratic formula, so we can say x is equal to minus 1 for sure, or x is equal to 10 plus minus the square root of 10 squared minus 4a C over 2A. So if you work this out, you will see that under the root it must be a negative value, I'm sure. So it's going to be 10 squared is 100 minus 4 times 37. Gives you negative 48. Can you see that? Since the under the root is negative, so what can we say? No solution there. Can you see that? Therefore, we can conclude, therefore, x minus 1 is the only factor of g of x, the only root of g of x. Which means to say that this graph will cut the x-axis at one point only. That's basically what it says. Okay. Then it says sketch the graph. So I need the space here now. Take this off. It's your turning point there. So when we sketch this graph, minus 1 is the only factor. So I need to represent minus 1. Also, what is your y-intercept on this graph? The y-intercept is at 37, not so. The y-intercept is at 37. So I'm just going to do the business more on top. You got your y and your x there, which is negative 1, 0. You put 37. It's all by approximation. Okay? Remember the turning point needs to be represented as well, which is at 3 and 64, which is double that length from the origin. So it's going to be 3 and 64, approximately. No? So here we go. From the point of inflection, we'll draw this graph. So we know the graph is coming down like that, and it's going up like that. Okay, you guys understand? You all understand? Okay. So the next question says, use your graph to determine, this is now number 5, use your graph to determine the limit of g of x as x approaches infinity. So g of x is the function. The limit of g of x as x approach infinity, which means to say it's going in that direction. What's happening to the graph? It's approaching positive infinity. You all agree with that, people? So the answer there is simply that it will be equal to positive infinity. Question 6. Sketch the inverse, the g of g prime x, which is the first derivative. Not so. So if you're looking at the first derivative graph, what is the equation of the first derivative? The first derivative? It was, 3x squared minus 8x, 18x plus 27. So if this was the graph, y is equal to x, and I must draw that graph. We know it's going to have a y-intercept of 27. Work out its x-intercept. We work out the x-intercept by letting y equal to 0. Not so. So firstly, that graph is smiling. Your x-intercept is 3, we work it out. Okay, and you've got the y-intercept of 27. And I must draw. This is what the graph is going to look like. And this is your f prime x graph. Can you see that, people? This is going to be 27 here. Then they want you to draw the f double prime graph. No, g double prime, sorry. Which means to say it's the derivative of that, which is 6x plus 8. No, 9x plus 8. 18. This is 18 here. This is minus 18. Okay, so your double prime is going to give you 6x minus 18. If I set that equal to 0, x is then equal to 3. Can you see that, people? So what I'm doing now is I'm going to draw the graph y is equal to 6x minus 18. That's a graph I'm drawing now. Why? Because why? The second derivative is defined by 6x minus 18. Alright, so if I draw that graph has an x-intercept at 3, and it has a y-intercept at negative 18, which is fairly low there. So if you draw that going through like that, there's the graph of the inverse function. This is the graph of, not the inverse but the second derivative, that was your first derivative graph. Okay. What do you notice? What is common about this graph here? All is to do with 3. Not so. So, after drawing a few of these graphs and comparing these graphs, you will come to the following conclusion. Okay? Another bell rang, so sorry about that. If f of x is given as that graph, the first derivative of x will look like that is positive, so the graph is smiling, and your second derivative of this graph will be an increasing linear function. Okay. However, your a value is negative, or the graph is decreasing and then increasing. Your first derivative will do that, and your second derivative will be a decreasing linear function. Okay, that's important to note at this point. Then, something else to note as well, is that if that is your point A and B on your x, then your x-axis here would be your A and your B. So, where the turning points occur on your cubic function is the same x values at which it will cut your x-axis. So, if you put that in context here in this graph, you will notice that the turning point and the point of inflection both occurs at 3. What is the x value of this turning point? Or the x-intercept is 3. Can you see that, people? Now, you see this x value, the turning point is also your axis of symmetry of this parabola graph, not so the quadratic graph. Can you see that? So, since that is the case, your point of inflection, your x value for the point of inflection also is the x value at which your straight line cuts your straight line cuts your x-axis. Now, putting that into account here, so let me just put this here as well. That is A and your B here, A and B. That will be the case here for A and B. Okay. Now, remembering this is your x-axis, no? Your x here.
So busy.
No, I'm not busy, my girl. For what? Have we sold out?
Sold out.
Yeah. Okay. Alright, so that's your x-intercepts, no? Now, your point of inflection is makes a different color here. Let's then call the x value for the point of inflection C. Okay, the board is not lined up now again. Let's undo that. Try again. Okay, there's a straight line I'm trying to draw, no? So that is C, which is your axis of symmetry, but importantly it will cut, your straight line will cut your x-axis at that x value of C. Can you see that, people? And the same thing there. If this is your C, this will be your axis of symmetry, but this will be that point. Okay. So that's the relationship that is actually happening between these graphs. Okay. Any confusion? No? Okay. In example 3, same story. Classify the stationary point, first derivative set equal to 0. Point of inflection, what do we do? Second derivative set equal to 0. Discuss the concavity, we spoke about that. Determine the roots, you know how to do that. Sketch the graph, sketch exactly the same as question 3. However, this is basically a decreasing graph. It's going down. Okay, as you can see that x is negative there. People, for homework is exercise 11. You give me number 1, 3, 5, 7, 9 and 11. You do those 5 sums for tomorrow. We only have 2 lessons before we're writing our exam. Okay. People, enjoy the rest of your day. Good morning, class. Morning. Hey.
I'm not coming to next classes today. So can I do work,
Why?
please? I'm not taking
Huh?
I'm not taking
Okay, Megan, just stop this. Yes? Sold out, Michael.